All right, that leads us to our last bit of this lesson, which is information that is posted in a table. And you really need to know this information. Basically, what we're going to do is I'm going to provide a description of what I see, and then the theorem that goes along with it. So, in this picture, what we have is that K is a tangent to the circle, and that K, I can see, is intersecting the radius. So we have basically a tangent, meeting the radius. What that means is that the tangent is perpendicular to the radius at that point that they meet. In the second picture, it's very similar. You can notice there's a difference. In the first picture, I gave you a statement. I said that K is tangent to circle Q at point P. In the second picture, I gave you a right angle mark. So that's what I see is I see a line is perpendicular. I'm using symbols, so this upside down T is perpendicular to the radius. What that means is that that line is tangent to the circle. All right. What we have here is that both segments are tangent. If the two tangents meet at the same point, which is what these are doing, so I have two tangents meet at the same point. What is true is that those tangents are congruent. They're equal to each other. All right. Oops, sorry. I had already typed all this up. All right, for this next set, I accidentally put I put the same picture in twice, so please cross that out if you haven't already crossed that out. What I notice in this picture is that I have in the same circle or in congruent circles, the chords are congruent. So AB is congruent to CB. And what that means is that their arcs are congruent, which means so the curved part from AB is congruent to the curved part from CB. So the straight part, the straight connection from A to B was equal to the straight connection from B to C. That means that the curved connection from A to B, the curved path from A to B, is congruent to the curved path from C to B. All right. For our final one of this page, what I have is kind of the reverse of what was in the first one here. In this circle, what we have is that the curved regions are marked congruent. So the curved path, like if you were at A and you traveled the path to B in that curved path, you would find that if you also started at C and traveled to B along the curved path, those were congruent. They're marked congruent. Because of that, that means that the straight path from A to B is congruent to the straight path from C to B. Of course, the straight path would be shorter, but we're not really concerned much with that. We're just saying that we know that since the curved paths are congruent, their straight paths are congruent. Again, please pause and write things down if you don't have them written down, as I am not doing this as if people were asking me questions or asking me to stop. All right. The picture here, what it shows is that I have a chord perpendicular to another chord. And not just perpendicular, it's cutting it in half. It's perpendicular bisector. So what that means is the first chord is the diameter of my circle. In the second picture, what I have is, and this is supposed to be the center. So I know that you can see it better on your paper than it is here, but it's not showing up very well in the PowerPoint. So that's the center. So what I have is a cord going through the center and perpendicular to another cord. So what I have, if it's going through the center, it's really a diameter and it's perpendicular to another cord. What that means is that it bisected the other cord. It cut it in half, meaning DE is congruent to EF. Those are the same length. All right. I need you to add this little part here that AB is congruent to CD, because that is missing in this picture. So it's kind of hard to show it, but like by marking, so that's why I need to write it, and I left it off of your notes. But basically, since the chord AB and CD are congruent, and this is in the same circle or congruent circles, that means that they are equidistant from the center, meaning EF is equal to EG. These lengths are the same. Okay? In the second picture, I need to draw these links in. So these links need to be the same. So what I have here is that the two chords are equidistant from the center. Remember, equidistant just means same distance. So they're the same distance away from the center. And what that means is that the two chords are congruent. The two chords are congruent. So CD is equal to AB. All right?